I'm Martin Beeby, and I work as a developer advocate at AWS. And today I'm going to be talking about containerizing .NET apps and deploying them to Kubernetes. I'm Martin Beeby. I'm at the Beebs on Twitter, if you're interested in following me there. I work at AWS as a developer advocate for .NET. So I show AWS to .NET developers. When in normal times, I'd be traveling around the world showing, different meetups and events, how to do stuff on AWS. I've been a .NET developer for, too long, maybe, about 20 odd years. And since the beginning, basically, of .NET. And I've been a professional developer since I was 16 years old. So that makes me, early 20s. Yeah, I'll do the maths on that one. So we're going to be talking about how you would take a .NET application and sort of deploy that to Kubernetes. But really, we're talking about creating containers so that we can deploy our applications to whatever container orchestrator we want. And fundamentally, they all have different nuances and different ways of working. But there are different orchestrators. One's Kubernetes. In AWS, we have another one called Elastic Container. ECS, the Elastic Container Service. But they're different, obviously. They have different licensing, they have different costs, they have different, all those sorts of things. But fundamentally, it's dealing with containers and working with containers. And so lots of the things that I talk to you today about containers will be relevant, not just for Kubernetes, but for any kind of container orchestrator, whether that be Kubernetes or ECS or whatever one you want to use. So I'm going to start today by telling you a little story about a gentleman called Guybrush. Guybrush is a cloud consultant, and he's just arrived on this island here to meet his new customer. And his new customer is Grog Computing. Now, Grog Computing are a big computing outfit. They've been, have got a huge heritage in developing software in Melee Island, which is where Guybrush is. And he goes to meet the CEO, CTO, and VP engineering of Grog Computing. Now, they are the official technology provider for the Pirate Festival. Now, the Pirate Festival is a large-scale event that happens every year on Melee Island, where all of the pirates get together and they drink grog, they eat great food, and fundamentally, they vote on all the best pirate things. And on Melee Island this year, Grog Computing have been given the responsibility of running that voting system. And that voting system is an application that's written in .NET. So the CTO explains that we provide a voting system for the Pirate Awards, but as many systems do, and you might have this yourself, is that you have systems which crash. If you have a .NET system of any particular age, you might find, it might not be the most reliable, or there might be problems with it. We used to have an application in the company I worked for previously that it kind of every Thursday, we would just switch the servers off and on again. Like in circulation, we'd have it load balanced, but we'd switch some of the servers on and off again because we were reaching like a memory limit. Now, we could have gone in and fixed that memory limit, absolutely, but we found it easier, or the IT team, for whatever reason in operations, decided it was just easier for them just to switch the computers off every Thursday. And you wouldn't be surprised how common that is. How common it is that customers that I speak to, they'll have something which has been built like 20 years ago. They don't quite know exactly how it works, or what really is behind that black box, inside that black box, and they will just recycle that machine every Thursday because perhaps it's got a memory buildup. There's a memory leak in the application. It gradually builds up. If you leave it for 2 weeks, it will eventually crash on its own. So it's better to do it in a responsible way. Every Thursday, we'll recycle it. So this is the kind of application these guys have got. They've got an application which is a little bit legacy. People don't fully understand how it works, maybe in the development team. They just know this thing where every so often it will crash for no particular reason. They don't really want to have to go and rewrite it because it kind of works. And they're using it infrequently in this instance because they're only ever using it really for the Pirate Festival. And so they don't want to have to rewrite it every year. But the problem is, the CEO is saying, well, if this voting system is unreliable under scale, and every year the Pirate Festival gets bigger and bigger, we're going to eventually get to a point where we lose our contract for future pirate festivals. So from a business point of view, we need this application to be running and reliable, but we don't really want to put a ton of engineering effort into making it necessarily more reliable. So the VP engineering says, look, we need to make the system easier to scale and just more reliable. Now that could result in a rewrite, but our cloud consultant's having a think about, how's this application set up? So he asks, look, where is the data center and what are you running this application on? How's it running? And so the board say, well, the data center is just through that door. So Guybrush goes through the door and sees that this is the data center which is running the infrastructure for the Pirate Festival. It's a single server running in a data center, not the greatest data center on-prem, and it's very much loved by the engineer, which is stroking that keyboard there. He's very happy with this system and he keeps it running and he keeps it ticking over. But to be honest with you, it's not the best infrastructure in the world. And so Guybrush has a think and says, look, I've got 3 things that I think we could do with your application just to make it a little bit more reliable and easier to manage. So firstly, we're going to containerize your application. We're going to take your application as it is without very many code changes. We're going to put it into a container. Second, we're going to move your containers to the cloud, get it out of the data center and put it somewhere where there is an opportunity to expand and scale across multiple machines, instances, and take some of the benefits of that cloud. And then hopefully we're going to then enjoy the reliability that provides. Without making any changes to the application, we're just going to change the way we operate it and therefore improve it. Now, this is a story, and the reality is, often you will have to re-engineer applications when you containerize them. But the idea is that you could containerize anything, whether that be a .NET framework application from many, many moons ago, which only runs on Windows. You can use Windows Docker containers and containerize a Windows-based .NET web forms application. All the way up to sort of modern times when you can take a .NET 5 application or a .NET Core 3.1 application, you can containerize that as well. In reality, it's much easier to containerize a more modern system than it is an older one, but there are ways and means to containerize any kind of application. And on AWS, you can run those containers, whether they be containers running Windows, Docker for Windows containers, or whether that be Linux-based containers running .NET Core or .NET 5. So there are lots of ways you can containerize your applications, and Guybrush here has got a three-step strategy that he's selling to this customer to say that this is how we're going to do it. So they say, great, this sounds good. Why don't you go and meet the dev team and we'll figure out how we start on step 1 of containerizing our app. So Guy goes and meets the dev team. This is the dev team behind the Pirate Festival voting system. Asks them a little bit about the system. What kind of system have we got? Where's the databases? How's things stored? How the things work? And the lead dev, she says, we have an ASP.NET app that's older than me. What can we do? How can we modernize this? How can we take it to the next level, make it more reliable? And so inside their applications, basically, it has been quite modernized. It's running a .NET Core application, just for simplicity in this example. But they're going to take this application, and the first step is really just to make it a Docker application. Like, how do we take a regular .NET application and containerize it? So we go over to Rider, look at the project, and we right-click the project, and we click Add. And then there's this option saying Docker support. Now that's going to say, what do we want to target the operating system? What we're going to run this on? We're going to choose Linux, and we're going to click OK. It's going to add 2 files, a Docker ignore file and Docker file to GitHub. And it's going to add this Docker file and Docker ignore file to our project. Now this is a Docker file. It's a multi-stage Docker file, which Rider has added to our project automatically. Now, if you're not familiar with Docker, don't worry. It's actually really straightforward what Docker does. And we don't really need to get into the nitty-gritty of how it works and why it works and things. What you should know is this is basically a file which can sit in the root of your project, and Docker can take that file, and then it understands how to take the files inside of your application and containerize them. And what it's going to be doing, if you see these statements where it says from, so on line 1, from mcr.microsoft.com/.net ASP.NET 5. That is a base image. So it's going to take that base image, the ASP.NET 5 SDK base image, and it's going to use that SDK, that base image, to start to produce builds. So in a Docker file, you'll see every place where it has a from statement, that's a new container. So it takes it takes the container, it does some work with it, and then it gets a new container, it generates a new base container, it does some work with it, then it generates a new base container. Now, a base container is basically just like I think of it in my head, I can think of it as like a little virtual machine. And that kind of virtual machine is the operating system and all the files in it. Now, these images, so anything which is in this from statement, this is an image, a container image. We call it a base image, a base container image. We're basically taking that base image and then we're adding stuff to that base image. In a few years ago, a Docker file would have just been it would have had one base image and then there would have been lots of commands. We've now got the ability in Docker to have this thing called a multi-stage build, which is having multiple base images throughout the Docker file. And so you'll see that in different places, it's taking, on line 1 there, we're taking from the ASP.NET 5 base image. And then on line 6, we're taking from the SDK image. Now, the reason why we're using an SDK image here is because we're going to do a build. So we actually do a build when we create when we're creating our container image, and it does a .NET restore. It copies the files into a working directory, and then it runs .NET build on the project, and it releases it to an output folder called app build. And then once we've built that application, we can go and do more with it. So we've got here the final image is basically, instead of using the SDK base image, we're going to take it from the base image, which is this one, and it will be just the runtime inside of a container. Now, the reason we're doing that, and the reason why we have different container bases, is because when we're doing at the build stage of our container, we need all of the SDK tools. We need to be able to compile an application and build it. But when we actually want to publish our container, we want our container to be as small as possible. So we don't really want it to contain all the SDK bits and gubbins. So we do the build, we get out the output, the DLLs effectively, we throw away the base container, and then we bring back in an ASP.NET 5 image as our base container. And that's just the runtime. So with a multi-stage build, we take the image, which has all the SDK stuff in it. Then once we've done our build, we throw all that away, really. We keep all of our build assets, and then we put it into a new container, which has a base image of the lowest common denominator. In this instance, it's a base image of ASP.NET 5. But it could be, you could go as far back, instead of doing that, you could pull just an Nginx container and run it inside of that. So basically, this file describes how we build our container, all the different layers in our container, and we end up with this container image, which contains our built application, which we can then take that image and we can deploy it to services. So I could take this application, I could go and deploy it to Kubernetes or ECS or something. Now, there is one other way. Now, I've done this inside of Rider, where it's generated me a Docker file, and then I'd be running some Docker commands to go and actually build that Docker image. We also have at AWS, we recognize that some applications, you might not have the source code, you might not have everything that you need. You just have the application, maybe running on IIS or something like that. So we've developed this tool called App2Container, which takes that app running in IIS or running somewhere, and it can take that and convert that into a container. So wherever your application is at the moment, whether it's, if you've got the source code and it's running .NET Core, or if it's an older web forms application running IIS, you can basically point something like AWS App2Container at the IIS application, and then generate a container from that. So there's multiple ways to create a container. I've shown you the developer sort of workflow of generating a Docker file, and then you do some command line tools to generate the image, basically run a thing called Docker build. Or you can use a tool like AWS App2Container. Take your existing application, put it into a container. And then once you have it in a container, then you need to go and put it somewhere. So there are many places where you can store containers. One is called Docker Hub. You probably hear about that. It's the sort of standard default place that you put container images. We also have a thing called the Amazon Elastic Container Registry. There are two flavors of ECR, which is how it's often called, ECR, Amazon Elastic Container Registry. We have the private version, which is called just Amazon ECR. And then we have the public version, which is called Amazon ECR Public. Now, the difference being is the ECR, Amazon ECR is private, and that would be great for container images that you don't want to be shared on the public internet. You don't ever want to share with them anyone outside your organization. You want them to be private and only be available to your organization, to people which you expressly give permission to access those containers. ECR public is for when you want that container and you want to publish it, to the greater world. And lots of customers and companies want to do this. At AWS, for example, we build container images for things like base images for builds. We have public container images for Lambda execution environments inside of a Docker container. Microsoft, you've seen there before, they are basically storing publicly the base images for ASP.NET and all the various other things. So there's lots of reasons why you might want to make a container image public. So you get to choose, well, where do you want to put this container image? Do we want to put it into ECR, Docker Hub, or ECR public, or wherever? But ultimately, you'll have to choose where you want to go and put that. Now, the sort of terminology is when you've got a Docker image and you want to put it somewhere inside of a registry, it's basically pushing it to a registry. So we push it to a registry. It then stores it in the registry. And then what we can do is our container orchestrators, or the services running our containers, will pull the containers down from these registries and then run them for you as applications. So ECR, we're obviously at the JetBrains Day today. So we have a tool inside of Rider called AWS Explorer. It's like an add-on, a plugin, sorry. We can add that plugin to Rider. It gives us a lot of functionality. One of the things it allows us to do is explore ECR. So you'll see in the AWS Explorer, you'll see this little thing here. It says ECR. I've got a container registry already created called Grog and Dash, which is where I'm going to store. It's my repository where I'm going to store my container images. This is built inside of ECR, Amazon ECR. So it's not public. This is a container just for my organization. It's not going to be used publicly by anyone. So I need to take my local image, the local project that I've got, and somehow get it into ECR. This is what I just showed you, what ECR looks like from inside Rider. And you can create those ECR repositories from inside Rider. But there's also a console. So the website, the AWS website, if we go to Amazon Container Services, there's a section called Amazon ECR. You can create repositories, you can add images, you can create permissions, do all the things that you might want to do. So this is my repository in ECR called Grog and Dash. And if I wanted to push a container image to this repository, there's a little button here saying view push commands. If I click on that, it explains to me how I take a local image and how I push it to ECR. Now, I've taken those lines of code and I've just put them into a slide, make it a little bit bigger and a little bit more green so you can read it. Now, the first thing you're going to need to do is you're going to need to log in to your repository. So you'll need, now this will vary depending on what you're using. If you're using Docker Hub, then you'll be able to do a Docker push to your Docker Hub account. But any private repository is going to have some way that you need to log in so that you can store and maybe even retrieve your container images. So this is how you do it in AWS. It's going to be different for different providers. I use the AWS AWS command line interface, or CLI, and we have a command called AWS and then ECR. and it says get login password, and it goes and gets the password for our ECR repository. The commands to do this are listed on that website. So this is just me repeating it here, but this would basically then retrieve the password, and you can see there's a pipe over here. There's a little pipe, and then it adds another command, which is docker login, and it takes the username and password it got from the first command, and it pipes it into that command. So then it does a docker login, and that docker login will log me into my repository. So now, anytime I do a docker push, I'm interacting with my private repository for my containers and not the public one, not Docker Hub. So then inside of my project, where the Docker file resides, so in my instance, it's just the root of the root folder. There's this Docker file, which Ryder added to my project. I can then just run docker build tag or -t grog and dash. And then you've got to put a dot, which basically means it's in this project, in this folder, right? So run it inside of this folder, basically take the files from this folder. So docker build and build the image and tag it grog and dash in this folder. It will then go and build using Docker. You'll obviously need the Docker installed on the machine that you're running this in. Now I'm going to be doing this. I'm doing this at the moment, like on my local machine, but in reality, you'd probably have like a CI/CD pipeline which did this. So it would take the source control when it's checked in. It would do a Docker build. It would push the container images over to your container registry. And in a lot of companies that I go to, they have that completely automated. So someone will check the code in to let's say GitHub, and then that will fire off a build, a GitHub action. That GitHub action will go and build the container image, and then it will push it to AWS ECR or Kubernetes or wherever it needs to go push it. So basically, all the developers will need to do is maintain their standard way of building their of checking in source control, and then the CI/CD pipeline will actually do the Docker build, will publish it to ECR or publish it to Docker Hub, and then deploy it ultimately to the Kubernetes service or whatever container orchestrator you're using. So run docker build tag grog and dash dot, and it will run inside of that project and we'll create a container image and tag it grog and dash. We can then say, well, I'm going to take that image and I'm going to tag it again. So I'm going to call it something else. Now, this is important because this is how we line up our local images with the things in our repository in the cloud. So I'm going to tag the grog and dash latest version, which is what I just built on that line before. I'm going to tag it with this quite long number, which is my account number .dkr.ecr EU1 North amazon.aws.com / grog and dash latest. So I'm basically retagging the same container image just with a new name. And then when I run this next command, docker push and that container, it knows what repository to put that container into in my account. So docker push, ordinary docker push would push to Docker Hub, but because I've logged in to my ECR account, it's going to push it over to ECR, and then that container now resides inside of ECR. So what we've done, we have taken a .NET application, we've used Ryder to generate a Docker file, we then built that Docker file using docker build, and we've tagged it with the correct name for our repository, and then we've pushed it to ECR. So now my application has been containerized in a kind of very simple way. Like I've not split anything out into microservices. I've not created multiple containers. We absolutely could do that. Not done any of that. All I've done for the moment is just take my monolithic application and published it inside of a single container and published it to ECR. Also, if you're creating, just because this is the JetBrains day and we're talking about Ryder a lot, if you're creating an ASP.NET Core application, there is when you're doing a file new solution or file new project, there is a thing which says Docker support, and you can add Docker support, and basically it will generate the Docker files for you when we start up. Now, the cool thing about Ryder is it recognizes that you have Docker files inside of your application. And so if you want to then go and do fancy things, if you want to basically run that Docker image. There's a whole an array of Docker support inside of Rider as well. So Rider understands Docker images. It can run Docker images. It even has some quite cool tooling to do live debugging of containers inside of AWS as well. I know that you can do live debugging of the Elastic Container service from within Rider as well. So it's quite cool what Rider can do with Docker images. But just to point out there, when you do a new solution, you have that option to add Docker support in that new solution window as well. Why does this, like, why would a customer want to do this? Why would they even want to go and think about containerizing their application? Well, I'll try and explain it a little bit here. So we've got this is the application kind of before. I know I had that example of just one single computer, but the reality is most companies would probably have some form of load balancer for any kind of external website, which would load balance over a number of virtual machines. So this is quite a common sort of architecture in an application, which I'll see in a customer, where you have, a load balancer which load balances across let's say three virtual machines, and each virtual machine has a copy of the web application on it. And they have some kind of load balancing strategy, which round robins to the different virtual machines. And maybe the load balancer will monitor health of the virtual machines as well. And if one of the virtual machines becomes unhealthy, it will load balance to the other two virtual machines. This is a standard way of setting up an ASP.NET application. One of the problems with this kind of setup, though, is, well, virtual machines are quite heavy, big things. So let's say we have an older application which has some kind of memory leak or problem. And as users come online and they start using our application, we're getting much more load going through to the virtual machines. And let's say one of the particular applications, it starts becoming problematic and we start using up our memory, gradually using up our memory, and may get to a point where we have some kind of critical failure in the application because of memory pressure. So that virtual machine here, that becomes broken. Now, in AWS or in lots of different cloud services, you can create systems which can auto-scale virtual machines. So we might have a system where we automatically go and either replace that particular virtual machine based upon a virtual machine image. We would maybe restart the virtual machine. There might be some kind of automation. Hopefully there's some kind of automation which does restart of that virtual machine. The problem with a virtual machine, though, is, let's say we're being really kind, virtual machine might take sort of 5 minutes to restart and get back into a position where it's able to accept traffic again. So if we've got this system where we've got three virtual machines load balanced, and one of our machines goes out of sync, that means it's going to be down for like 5 minutes, which means that the pressure is going to increase on these other two virtual machines. And what you can have then is a cascading failure. So potentially the issue which caused this issue might be present in these other virtual machines, and gradually the memory pressure becomes too much and all of the virtual machines are problematic. We've still got lots of load coming into our application, and we're having trouble restarting the applications because every time it's coming in, it's overpowering the system. And this is like creating like reliability problems because we're not delivering at full capacity. And it's very common that these sorts of issues might occur. Now, let's have a look. Well, what happens in a containerized application? Now, let's just say we've taken our application, we've containerized it, we put it into a container. We've not done anything particularly fancy with it. It's just now sitting inside of a container for us. So we now have this thing called a cluster. Now, it doesn't matter if you're using Kubernetes or using ECS or whatever container orchestrator, they all have this concept of a cluster. Now, a cluster is made up of machines. It's made up of virtual machines or instances, as we call them in AWS. And you might have just three, we might have three machines sitting in the background there, which actually make up this cluster. But when you say, okay, I want one container to be deployed. Okay, I want 2 containers to be deployed, let's say. Then the load balancer will balance the load between these containers, which sit inside of this cluster. Now, the difference being is, let's say we get a particular big spike in traffic, and maybe my autoscaler for my container orchestrator says if I get more than, I don't know, 80 concurrent requests, add a new container. And so we gradually add more and more containers to our cluster to deal with the load. Now, let's just say we haven't made any modifications to our application at all, and it still has this problem where, for whatever reason, when enough people use it, it has some kind of memory leak and the application crashes. Okay, so these containers start crashing because they're starting maybe getting too much load. Well, the difference with containers and with virtual machines is that we can add them because the orchestrator will see that these two have failed because maybe we've got health monitoring, basically it monitors a URL or looks at port 80 and says that this is no longer responding. And so it will take those out of circulation and it will add 2 new fresh containers. Now, you might be saying, well, it's the same as what happens in a virtual machine, but the difference being is that these containers will start up we're talking like milliseconds, not minutes. So we can get back to the same level of, of however many containers we have in our cluster, or add more at will to deal with our application. It doesn't matter that the containers keep crashing maybe after every 5 minutes. Well, it does, but it matters, but it matters less for reliability because the container orchestrator just keeps replacing the containers. It removes the unhealthy one and adds them. Now, I'm not saying that's an ideal solution, but what I'm saying is the customer experience is different. We no longer have a system which is failing or has cascading failures. We have a system which is failing, but it's still managing to stay online and it's still managing to service our customers' needs. And fundamentally, it is more reliable. That's the key here, is that we're taking the same application, making no code changes, but we're able to make it a little bit more reliable in our applications. So that's cool. So we've got our container application containerized in ECR. Now we have to think about, well, how are we going to actually run this container? And to run that container, we're going to go, I'm really sorry. Someone just told me to up my volume. I only just saw that, and I know it was a while ago that they asked me. I'm going to put it up anyway. I'm sorry that if my microphone's a little bit low. So this particular user, the Guybrush is now thinking, well, how do I run this container? How do I make that container run? So Guybrush goes to his local AWS advocate. This is an example of an advocate, and asks, well, how do I run this container in production? What should I do? And AWS have lots of ways that you can run a container in production. I need to scale my Docker containers. And there's many ways that you can do that on AWS, but let's just use Kubernetes because it's an example of a good way of doing it. And whether or not you use AWS or not, you could take this knowledge and use it with different providers as well. So just to sort of highlight the 2 different ways that you could do things. There's a service called, and I've mentioned it before, Amazon ECS, and there's a service called Amazon EKS. Now, I mean, the difference being ECS was developed before EKS, and it's the way that we've been running containers in Amazon for a long time. We've got huge customers using ECS at massive scale. Customers which are doing all sorts of building all sorts of interesting sort of things. Customers like Netflix and various others who are doing interesting things with that. But it is proprietary. It is ours, but it's very scalable. It's battle hardened. It's extraordinarily reliable. We also have Amazon EKS. EKS is basically a managed Kubernetes service. Kubernetes is open source, originally developed at Google. It works slightly different. But it's fundamentally the same sort of concept. And at Amazon, both these services can kind of run any kind of container. So you can run .NET Core on Linux containers. We can run .NET Core on Windows, or we can run .NET Framework on Windows containers on both of these platforms. And what do I mean by that? Well, what I mean is that what I built, it looks like I've got, hold on one second. I've just got a child who's come to see me. Darling, I'm presenting. Sorry about that. The kids have just finished school in the UK, so they just came to my office. They didn't realize I was presenting. So where was I? Yeah, so you've got Linux containers, containers on Windows, and we've got .NET Framework on Windows. Now, on AWS, we support Windows and Linux containers. We've built Linux containers up to this point, but you can build them for Windows as well. And what that means is basically the infrastructure, the cluster that it runs on can be made up of either Linux servers or Windows servers. And for both ECS and EKS, we support both those as nodes. So you can have either Windows or Linux servers or a mixture of both. And so it means that you can run any kind of container. Now, that's not true for every provider. We were the first to add Windows support for ECS, and we were the first to add Windows support for EKS. So if you want to run a .NET Web Forms application, and that has to be built for Docker for Windows because it only runs on Windows, then you can use either of these services and run those things. And we were the first provider to support Windows on both of these container platforms. So Kubernetes is that ability to take those containers and we call them container orchestrators because they kind of like orchestrate our containers in production. We define how we want our application to run in production, and then it's Kubernetes' job to make sure that what we've described in our definitions is how the application runs. Now, it's open source. Lots of different providers, cloud providers, use and support Kubernetes. It was originally built by Google, and we call it a container orchestrator. So a node, you'll often hear me referencing a node in Kubernetes. A node is the smallest unit of computing in Kubernetes. So I think of it as like an EC2 instance on AWS. EC2 instance is a virtual machine, effectively. So a cluster is made up of virtual machines. So we might say, I want a cluster of 3 virtual machines in my Kubernetes cluster. And what Kubernetes does is it installs on those machines, and it then basically creates a cluster from those machines. And when you say I want to put a container on my cluster, it's actually going to be placing that on one of the machines, the virtual machines. To you as a developer, you just see it as this big cluster, but under the hood, it's made up of machines. Now, if one of those machines fails, Kubernetes will recycle that machine, replace that machine, rebuild things that are on it. It will move nodes from failed machines to working machines. But that's not going to be impacted by your application. See, if your application has a memory leak or some kind of critical failure, that's not going to bring down the virtual machine. That's because it's in a container, it's sandboxed. The reasons why virtual machines might fail in a cluster in Kubernetes would be potentially like a hard disk failure, things physically going wrong, network card failure in the actual physical machines which run it. In those instances, Kubernetes knows how to then restart the machine or rebuild the machine or create a brand new machine and add it to the cluster. So if you say I want 3 nodes inside of my cluster, Kubernetes is responsible for making sure that you always have 3 nodes. In AWS, I won't go into the details of it, but we have a thing called availability zones inside of a region. Often is the case that when you build a Kubernetes cluster, we say that a node should be placed in each availability zone. And these availability zones are separate sort of pieces of infrastructure. And that means that your cluster, it's very unlikely that you'll have multiple availability zones failing at the same time. That we've made sure that they've got separate power, separate cooling. They are far enough away. These availability zones are far enough away from each other geographically, so that like a bolt of lightning wouldn't take out both AZs. So we can create these clusters of nodes across availability zones, which means that it's really unlikely that we're going to have we're building resiliency into our application by creating these clusters which span multiple availability zones. A pod is a set of containers that make up a single microservice or a single application. So you might say, we've got 3 or 6 or 9 containers in a pod, which make up this particular portion of my application. And a cluster, I've already discussed it in Kubernetes, is that pool of nodes together which form and create this cluster which we can deploy our containers onto. Now you can build a Kubernetes cluster from virtual machines or even bare metal machines if you wanted to, and you can deploy it yourself, and there's instructions on how to do that. It's building a cluster the hard way. It's very infrastructure-y. There's a lot of networking you have to get right. But for the vast majority of people, specifically if you're a developer more like myself, then you will probably want to go to a managed service. And so the easiest way to create a cluster is to use a cloud provider like AWS. Our service, the Elastic Container Service for Kubernetes, or actually it's changed that. Yeah, Elastic Container Service for Kubernetes, or Amazon EKS, is a fully managed Kubernetes control plane. And it's as easy as going to this console in the cloud and going, I want to create one of these things. Obviously, you can do it all from APIs as well. You can do it from command line interfaces. We even have specific tooling to help you build these clusters. But the simplest way, go to the website, say, I want to create an EKS cluster, give it a name. In this instance, we're going to call it Grog and Dash. You pay for the control plane, and you also pay for the individual nodes that make up your cluster. So if you say I want to have 3 nodes in my cluster, 3 EC2 instances in my cluster, which make up my cluster, then you're going to be charged for each of those individual machines as part of your bill. So here we can say, well, I'm going to give my cluster a name. I'm going to choose a Kubernetes version. It's quite an old version, but never mind. I'm going to give it a name, a role name. In AWS, this is one of the ways that we manage security. I'm not going to go into that, but it's just basically the security, the role that we give those machines so they can talk to other AWS services. I'm going to create this inside of a VPC. In AWS, VPC is a virtual private cloud. It's like most people build their infrastructure inside these VPCs. It's like a little area, a little private network that you can create. We can either choose an existing VPC or we can create a brand new VPC. And it allows you to configure things like subnets and various other different things. So you can position it inside of next to other AWS resources or access other AWS resources. You can put it in a private area which isn't accessible from the internet, or various other things that you might want to do from a networking point of view. But I'm just going to accept the defaults. It's going to create me a brand new VPC. I mentioned what subnet I want to put it in. These subnets is the way that we can place different nodes in different availability zones. I've got 3 subnets inside of this VPC. Each one of those subnets exists in a different availability zone. So I know that if I put a node in one of those subnets, it's going to span multiple availability zones. And then the final thing is a security group. A security group in AWS is a little bit like a configurable firewall. So a security group would say things like, I'm going to allow port 80 or allow port 443 or whatever ports that you might want to open on those machines. You basically configure it once in a security group, then you apply it to the nodes. And this is the same with EC2 instances as well. You apply a security group, and then instead of going to the individual machine and opening up ports, that security group will, if it's applied to 1 or 10 machines, it will open up the ports based upon that security group. So it's a bit like a customizable firewall. That's the way I think about it anyway. So once we've done that, we created our Grog and Dash cluster. We end up with an endpoint that we can communicate with and start working with. So the way that we would work with a cluster is we would use our tooling. And there is some open source tooling, kubectl, which is a way of interacting with your Kubernetes cluster. The only thing which is different, I guess, if you're deploying it to AWS, is that you're going to have to log in to your cluster. So there's a little bit of work that you need to do just to log into your cluster. But once you've logged into your cluster, and there's a couple of lines that you need to run to log into your cluster, once you've done that, then you will be able to just use kubectl just like you're dealing with any other Kubernetes cluster, whether it be on Google's cloud or Azure or any other cloud provider. So this is kind of the command that you run to get the credentials for that cluster. So I use AWS EKS. I say I'm in the region EU West 1. I'm going to update my kubeconfig, which is a file on your machine, which basically is the connection to Kubernetes. I'm going to call the cluster Grog and Dash, and then it's going to look for that cluster in my account, Grog and Dash cluster, and then it's going to basically take the connection string effectively, and it's going to save it to my local kube config file. So now whenever you use kubectl, it's going to be actually executing against this cluster. So that's the only difference. That's the only line of code that we're going to have to run to connect these things up. And then we can start interacting with our cluster. So I can start running commands, for kubectl commands, like kubectl get services. And here I've got a service running, and it shows the service and the cluster IP and the ports that are open and how long it's been running and various other things. Now, I mentioned a node in AWS is an EC2 virtual machine. It's like an instance, a virtual machine. So we create these nodes and we add them to our cluster. If you want to run Linux containers, then you need to have Linux nodes. If you want to run Windows containers, then you need to have Windows nodes as part of your cluster. We pay for each individual EC2 instance. And in this example, we're going to have 3 nodes in our cluster. So I added them as part of the creation. And so now I've got 3 nodes added to my cluster. They've been added, they're only a minute old. And they're individually addressable EC2 instances. You can go into your account and you can actually see these machines. They've got IP addresses. You could access them individually if you wanted to. You can have fun, like you can restart them and you can watch Kubernetes go and recreate them. If you deleted one or something like that, it would just be recreated by Kubernetes. So these instances are being managed by Kubernetes, and they're forming this cluster. Now, if we want to apply an application or get our containers to to this Kubernetes cluster, what we have to do is we have to send our Kubernetes cluster a description of the application we want to run. And basically the description file is either JSON or YAML, and it describes what containers we want to run, what pods we want to run, how many containers we want, where we get the container images from. And I'm using it here as a file, but it can even be a URL. You can point kubectl to a URL in GitHub. It's a GitHub file, and it would deploy that application directly to your cluster. So there's lots of examples on the Kubernetes project of sample applications you can just basically apply to your cluster, and it will go and build that application inside of your cluster for you. This is roughly what a Kubernetes file looks like in YAML. So I here have, that Grog and Dash, that particular Grog and Dash container that I created earlier. You can see I have it over here, and it's pointing to an image. It's actually pointing, I've just realized, to my Docker version of this rather than my ECR version of this, but it's saying this container image comes from the Beebs/Grog and Dash latest. I know it's Docker Hub because it doesn't say anything about the container registry. It just says the name. And that only happens with Docker Hub. So my Docker Hub username is the Beebs. So it's saying the Beebs Grog and Dash latest. Go and pull that image from my Docker Hub. You might, if I was using ECR, you would see a URL to my ECR and my image here. And it's saying always pull the image directly from the container registry. And it's saying how big do I want my container registry container to be? CPU 100 and memory 100 MI. I'm saying that I want port 80 to be open on that particular container, and I want 6 of these container images as part of my front end of my application. I think I give it a name. I label it Grog and Dash front end, this particular set of containers. What I want is a load balancer, which is what I'm going to put my domain name at, which then load balances across those different containers that I've created. Now, this is an example of the actual application. My application doesn't just consist of my ASP.NET application. It actually uses Redis as well. So as part of that, I've created a Redis cluster in my application as well. So you'll see, if you look through this YAML file, which is over on my GitHub, you'll see that there's a Redis file. There's a Redis, it will create the Redis containers, the Redis, the master and the slave containers. It will then create a thing called a load balancer. So you can see on line 91 there, it's creating a brand new load balancer. Now that's going to listen on port 80, and it's going to select anything which is labeled grog and dash in the tier front end. So it's basically going to be a load balancer which load balances across any of the pods, or the pod called grog and dash front end. And then I've got a deployment in front end with 3 replicas. You can see that on line 103. So here I've got this. I've got a cutout of that particular piece of YAML, and I've got 3 replicas. So what it's going to do, it's going to create. It's going to basically create this infrastructure for me. Sorry, I had 6 replicas originally. Did I? Yeah, 6 replicas. You can see at the top there. And then, so I would have had 6 containers. And then if I go into my YAML file and I were to change that 6 to 3, what would happen is that the container would, it would scale down the containers. Instead of having 6 containers running, I would have 3 of those containers running that front end application. So the way that we describe the application, how many containers, what containers, where the containers should be running, what other containers are working, how things communicate and network, that's all described in this YAML file. So a developer would construct the architecture for that application in one of these YAML files. And if you ever want to change it, you want to add more containers, we just go and edit the file and apply it to our Kubernetes cluster. We can do this manually, like I'm doing here, or we could have it working a little bit smarter, automated. So let's say we have a system where we're monitoring the number of requests that are coming in. We could scale the number of replicas that we have of that particular container to handle a bit more load. There's lots of ways that you can adjust that. And basically, if you adjust this file, apply it to our cluster, it will alter the application architecture for us. Okay, so we've built the site. We've containerized our .NET application. We've rebuilt the site on Kubernetes. We're now in the cloud. We're set up a CI/CD pipeline so that we just check our code into GitHub, and then we have a continuous integration platform which will take our Docker builds, build it, push our containers to ECR, and then fundamentally our build system will deploy to Kubernetes by just taking our service.all.yaml file and running it against our Kubernetes cluster, and it will then apply that to our running service. So we've basically taken this application. We've not really changed any of the code, but what we should have done, what we hope we have done, is made the site more reliable. And even though it has this problem where memory keeps on crashing the application, we can still build a more stable system using a container orchestrator like Kubernetes. So if nodes fail, then they'll be recreated. If pods die, the system will re-add them. It will require very little human intervention. You know, if servers are failing, Kubernetes is going to replace them. If containers are crashing and they're becoming unhealthy, Kubernetes is going to replace them. There will be times, of course, when we have to go in and manually fix things and have a look at why the system's failing, and that requires us to add things like monitoring and logging, which is a whole different talk. But fundamentally, what we should have is a system which looks after itself. It makes sure it has the right number of nodes. It makes sure that the containers are as we've described them in our YAML file, and it's constantly trying to bring us up to that level. So if containers are dying, we're going to be adding new ones. Kubernetes is going to be adding them. We don't have to manually intervene there to do that. Now, one of the pirates, though, Grog Computing says, "I'm sorry to interrupt. This sounds great, but it's a little bit confusing. Why do I need a cluster?" And it's a fair point. And we thought about this at AWS, and we said, well, why do you need a cluster? Why do you have to describe the infrastructure underneath it? Why do you have to say, I want 3 machines? Isn't there a way which we can improve this? Now, we have a service in AWS called Fargate, which actually, we have this service called Fargate, which allows us to run containers in our infrastructure. So we basically manage a cluster, a really big cluster. And you can give us your container images, and we can run them in our cluster rather than in your cluster. That means that you don't have to manage the machines that underpin the cluster. You just have to give us your containers, and we'll run them in Fargate. Now, Fargate was added to our other container service, ECS, quite a while ago, and it was very, very popular because it meant that people no longer had to worry about creating these clusters. They would just basically describe the applications they want and say, I want these containers to run on Fargate, rather than my own cluster, and they would just run over in Fargate. We thought it would be quite cool if we could bring this to Kubernetes. So about a year ago, we added support for this concept. I think we're still the only cloud provider which do this. And it means that instead of having to create a brand new Kubernetes cluster and say, I want this number of, I want 3 machines, you could just build a cluster, build a control plane. And then when you're describing your application, you can say, I want these particular containers to run on Fargate rather than running on my own individual cluster, which means that the benefit of that is that, let's say I've got 1 container running my application, and then I've got this really busy day when the Pirate Festival happens, and I want to scale up to 20 containers. Well, with a regular kind of system, I'm going to have a cluster of a certain size all the time. And we'll scale the number of containers up there, but it's always going to be that same thing. So with Fargate, what we can say is, well, you just ask for more containers and we'll scale it and we'll charge you based upon how many the number of containers and the amount of compute that you're using inside of Fargate. So if you're only running 1 container, you're only paying for 1 container. If you're running 20 containers, you're paying for 20 containers. So it makes it more serverless. We call it serverless because you're no longer managing the servers or the cluster underneath it. So that's a newer feature inside of EKS, which allows you to avoid the requirement of having a cluster and just run it on our cluster for us. So, I mean, fundamentally, the way that Fargate is working is that usually we have this virtual private cloud, or the VPC, over here. And you would have your cluster, which is made up of your virtual machines. There'll be virtual machines which actually make up this cluster. There might be 3 virtual machines which make up this cluster. And that cluster would be able to communicate to the databases or to Redis. These might be outside of the cluster, maybe running in one of our other services, because it's inside the same virtual private cloud, the same network. What Fargate does is it creates a network, an ENI, or a network connection between our cluster and your VPC. And then basically you don't have to have a cluster anymore. You just say you want to deploy, there'll be a control plane, a Kubernetes control plane, and you say, I want to apply my file to that control plane, and then basically it will place the containers in our system. And the cool thing is, obviously, we manage all of this. You don't manage any of that anymore, and you only pay for the things you're using and not for the containers, which you aren't, not for the entire cluster, which you might not be using all of the time. But because we make this connection across from Fargate to your VPC, it feels like it's on the local network, so you're still able to contact local resources like databases and Redis and those sorts of things. So we've now got a system which is running. The Pirate Festival, where people are able to vote, it's working, and it's all running correctly. All great. So if you're there, you can have a little quick show of how this system works. So if you just scan this QR code with your phone, it will take you to a website in your browser, which probably just says something like, please wait, like that. And then I'm going to ask if we can use it. So if you go to that pirate.thebeebs.net, or just scan that QR code, you'll see this please wait sign. And once you see that please wait, then we'll say either coffee or grog. What do we want to vote on? I'm going for coffee personally, rather than grog. So we've got people out there in the audience voting on this. This is a containerized application. Oh, it seems like grog is much more popular. Let's have a look at, very much more popular. So 15, 16. Let's go into sword fighting or pillaging. Which do we prefer? Sword fighting or pillaging? Which is the favorite? Pillaging. I'm going to go for pillaging. No, actually, I'll go for sword fighting. I'll actually refresh the browser so I can vote again, because I've not really built much into this system. But we can see our application's running. It's being able to scale. Our containers are able to scale. It's running inside of Kubernetes. And for us and for our customers, Kubernetes has worked and it's scaled. And we've been able to take new life into this old .NET application. And fundamentally, the whole reason we do this is because it's reliable and it costs us less, because you end up not paying for all the infrastructure you're using, or you have to use to scale the application at its peak, but you can start paying for the application only when you need it and only pay for the compute resources when you need it. Now, that's all from me. This has been containerizing .NET apps and deploying them to Kubernetes. I'm Martin Beeby. I'm at the Beebs on Twitter. If you've got any questions or if you want any information which I've talked about, then please do contact me on Twitter or ask a question now, and I'll try and answer you as if I can. Thank you very much for listening, and hope to see you again.
Awesome. Thank you, Martin.
It's a pleasure.
All right, and we're unmuted. Yes, probably the first time after a session that worked out of the box in first time. Perfect.
Cool.
and voting as well, which is always good.
Yeah.
Sword fighting forever. That's it.
Yeah, exactly. Yeah.
I voted pillaging, actually.
Of course you did. Of course, it speaks volumes about you, Martin. It really does.
When I said pillaging initially, I kind of realized that I said pillaging, and I was like, no, what will people think about me? Like, I should definitely vote sword fighting. But yeah, it's all good.
It's only a demo, right? I mean,
yeah, exactly.
But we love your slides. It's a fantastic sort of Monkey Island thing going on there. And we did have a comment as well, actually saying that somebody was only watching because of the Monkey Island slides, which I think is a compliment. But we'll go with it.
Yeah, not me, not the content, just the slides. Yeah, just the reminiscing about Monkey Island. For those that don't know, by the way, if you're confused as to all those graphics in there, they do belong to a game called Monkey Islands that used to run on the Amiga. Not everyone will know what that game is, but if you're of my vintage, then you will.
Yeah.
All right. People watching the stream, if you have any questions, do keep them coming. We actually already have a couple. Let's maybe start. It's probably more an opinion than something else. It's actually one of us who came up with this. Okay. Looking at the diagram and the fact that everything can just crash and restart and so on is kind of like the antithesis of what we do at JetBrains with profiling and things like that.
Yeah.
But definitely it's much better than just having to jump in and hair on fire situations where you have to jump into a VM and start troubleshooting. You can leave it running for a night and have your containers reboot and restart and just take the time to investigate whenever you're willing to.
Yeah, I'm not advocating this as an architecture strategy, by the way. Like, I'm not saying that that's what you should do. What I'm saying is that it's actually a really common reason why people move to containers is just to kind of get a hold on their application a little bit, because you can start then, once you've got it into a system where you can start scaling much, and it becomes easier to scale it as well. You can move up and down and add more containers and reduce containers. It gets you to the point where you can maybe have more reliability, and then frees you up to then start thinking about, okay, how do we start really figuring out how to improve this application? How do we start profiling it? How do we get to the bottom of that memory problem that we had? It gets you away from the problem a little bit, so that you have some time to think about it. So it's just another. I mean, and this was just one customer example. There's lots of reasons why people move to containers other than that, but that is quite a common reason.
I think we've all been in a situation where you have to reboot a server because there's a memory leak. That just happens. It does. Yeah. As best as you can to write good code, you are going to hit that situation at some point. And yeah, reboot, restart, then fix. I mean, you need to keep the service running.
I'm in the point where sometimes, and I'm sad to admit it, I've written applications where I've had to reboot the browser just to rerun the application every so often. It happens, and sometimes we can't always get to the bottom as quickly. But when you have services which are able to scale at will elastically, then you can recover from these kinds of problems much more quickly, cover them up from the user, because failure happens. In the best written systems, failure happens. So if you're able to somehow add more nodes and recover a little bit from a complete system failure, rather than having to take 20-30 minutes to reboot your machines and rebuild the cluster and take traffic from the load balancer to just recover the machines and then apply it gradually. It makes all of those sorts of things easier to deal with and operate.
Yeah, so I mean, I had a question off the back of that actually, because during your session you were saying, like a VM could take like 5 minutes, say, to reboot, but a container can be up in milliseconds.
Yeah.
Why is there such a difference in speed there?
Well,
what's the magic going on?
Well, basically, you're sharing a kernel, so that you're not having to restart the hypervisor or the thing at all. You're not having to restart the entire machine, effectively, you're sharing, a container shares the kernel. And so it's only restarting the little piece of compute which is actually running the application effectively. It's running that container up and down. Containers, not all containers start really quickly, especially when you're looking at Windows for Docker containers. If you're containerizing an older .NET Web Forms application, then you might find that it does take a little bit longer to start the container. I've seen customers as well which have like done things like, they're adding sort of databases to containers, or they're adding sort of permanent storage to containers, and that will add to the speed in which a container can start. But fundamentally, you're not waiting for the whole operating system to come back up. You're just waiting for your portion of the application to come back up, and that's why containers are much quicker to stop and start, because you're sharing a kernel. You're not having to rebuild the whole machine.
And I guess leading on from that, I kind of get then from that, how a Linux kernel, container works, because as you say, you're sharing the kernel, and it's the user mode kind of stuff that you're having to restart. So then that's going to be quicker. That's all built into Linux, and it has been forever. Does Windows work the same way? Because again, I don't know enough about how Windows containers especially work. Is that the same? Are you sharing the Windows kernel, or are Windows containers implemented differently?
Yeah, so containers has been around in the Windows ecosystem since Server 2016, but I think is it Server 2019? I think that I mean, you can look at the details of how Microsoft have done this. They've added support for the kind of containerization that Linux has to the newest versions of the Windows Server. So it's built into the server operating system. Prior to it being done by Windows, they were using clever virtualization layers and stuff like that. Completely beyond me technically. I don't really know how any of that works. I am a developer, and I care. I'm way above that level. I don't delve too deeply into.
Yeah, I know the feeling.
But Windows containers. I mean, it's possible on Windows containers. We're obviously Docker, and there are other ways of containerizing applications. You don't have to use Docker, but Docker is the kind of the standard, or the de facto standard, and Docker worked with Microsoft really heavily to make sure that they could run Windows Docker on Windows. But there's I've used to work at Microsoft. I've not worked there for years, but there's lots of work that's gone on inside of the sort of the core of Windows to enable containers and Win containers. I personally use Linux containers exclusively. I don't have any Windows Docker containers. I just know it's possible, and I know that we've worked so that you can support it in AWS. But really, the magic, is at a server level, and it's Microsoft and Docker which have been working on that.
I guess you'd be more inclined to use a Windows container if you're using .NET Framework rather than .NET Core. If you're using .NET Core, you could probably favor Linux, I guess. Yeah,
almost certainly. I mean, I'm sure there's reasons why you would maybe want to run .NET Core or .NET 5 on Windows, but I don't. If I'm containerizing them, I'm doing it on Linux. Obviously, with .NET Framework, like full framework, it has to run on Windows. It uses Windows. It uses elements of the Windows operating system, which .NET Core was abstracted away from. That's the whole reason why .NET Core and .NET 5 are so exciting, in my view, is that they're no longer pinned to Windows operating system. So
yeah, absolutely. Cross-platform is good.
Yeah, if you're calling into a web forms, system.drawing or whatever, you're actually going into the Windows internals at that point. So it's not just at a software level. It's at a it's ingrained into the operating system. And so, I'm not saying I would advise that like Windows containers that run on the Windows operating system are harder to work with. They're not as common. And generally speaking, if you would generally favor Linux containers, I would say. For the if not just for the basic point, is that Linux servers generally are cheaper to run. For the same compute, you don't have to pay the license fee. So. Yeah.
A good point has also been made in the comments just now, actually, for sticking with Windows and .NET Framework, is that there are still many components, such as Crystal Reports, apparently, that don't yet work on .NET 5. So that is obviously a very good point. If you have dependencies which require .NET Framework, then yes, you're going to be.
And so you could have a system where you have a cluster which is made up of Windows. Like you've got one Windows node, and then you've got like 5 Linux nodes which make up your cluster. And you could say, okay, I've got this Crystal Reports API thing, which runs on the full framework, and I've containerized that, and that runs on Windows, and it will run on Windows in your cluster on your Windows node. And then everything else is .NET on Linux, and that's gonna run as containers, still talking to each other, still able to communicate over inside the cluster. But one of those containers, it just happens to be Windows. Just because you're using Windows containers doesn't mean you have to use it throughout your application. And Crystal Reports, system.drawing, those sorts of things are tied very much to Windows, and so you do have to architect around those.
Yeah, cool.
Cool. Do we have time for one more? I guess we have time for one more.
Yeah.
That also came in through the chats, and that was about telemetry and failure feedback, like logging and so on. Is there an easy way to get logs from your cluster, from your applications, and start looking into what is going on in there?
Yeah. To be honest, I don't operate many clusters at scale to the need to look into it. But there's any open source tooling which runs with Kubernetes. You can do, and there's tons of telemetry and logging systems for Kubernetes which you could run and use. I'm not going to make suggestions about which ones are the best because I frankly don't know. But it's a very broad ecosystem, and that's true of Kubernetes and ECS. We have systems for both of those container platforms. We have things like Firelens for ECS, which is a built-in sort of way of taking container logs and putting them into somewhere else. And but there are tons and tons of companies out there which are building open source tooling and also proprietary licensed tooling to help you with that sort of stuff. So yeah, we obviously there is basic logging and stuff, but most of the customers that I speak to which are using this stuff in anger are probably using some third party or open source tooling to kind of deal with their logs and things.
Cool. All right, then I guess we're almost out of time. So thank you again
Can I squeeze one last question in, do you reckon?
If it's the last one, yeah.
Yeah, a question about CI build. You were mentioning about pushing an image as part of your CI build. What about sort of best practices, I guess, around that? Would you do that on every build, or would you do it on only on a proper production released type thing? Is it like a deployment build? And what about sort of cleaning up and things like that? I don't know how heavy it is to push an image to as part of CI.
I mean, it's not heavy, and you absolutely can do that. So depending on your CI/CD pipeline and stuff, you will choose exactly how you want to do deployments. Do you want, often, you see how I tag that image, I tag that container with something. Now, in the examples that when I use Kubernetes, the way that I've managed this is that when I tag the container, I tag it with the ID of the check-in from GitHub. So it'll be like the long GUID that you get basically with each check-in. I tag each container with it, and then when I deploy it, I alter this is all automated. I alter the Kubernetes file to change the container image to be the container tagged by the GitHub repos ID, and then that's deployed. I do it basically on every check-in, usually every check-in which passes the build and passes tests, and I have a little pipeline which I build inside of. We have an AWS tool which does this, which provides a pipeline, and that has the ability to do, run a suite of tests, and if the tests pass, then it will then ultimately deploy to Kubernetes. If they don't pass, then it will raise an alarm. But you could also, put in a manual step there to, it requires a person to actually press a button to push it. Or maybe you will only do it when you're checked into a specific branch. There's lots of different ways that you could manage that. So not everyone will do it on every single time that you push to a particular to the main branch, let's say. But maybe if you've got a release branch, you would do it to that. So however you want to deploy, you can do it. But the common workflow which I use is I tag every container with the Git ID. And that's useful because then when you look at kubectl and you can see the containers that are running, you can see the tag on them, and then you can pin that back to a specific point in your code. Like, okay, that's that particular code base that I was running or built that container. So you can, be a little more specific about what version of the code broke the system, if that makes sense.
Yep, that sounds good. That's always good to know as well. Cool. Thank you.
Yep, absolutely. So yeah, thanks again for your session. I guess we'll bring in our next host, the next speaker. Thanks again for replacing one of the speakers on such short notice. And yeah, I guess we'll see you around.
Yeah,
Thank you.
great session. Thank you very much.
Take care, Martin. Bye.
Bye now.